In the last video, we discussed what happens when we have an unequal number of protons and electrons, and we called those atomic particles ions. Now we're going to look at what happens when atoms can differ in mass by varying the number of neutrons that they contain. So atoms with the same number of protons with varying numbers of neutrons are called isotopes. If we look at some examples of these isotopes, for example, if we take magnesium, there are three different isotopes which exist for magnesium. There's magnesium 24, which has 12 protons. It has 24 minus 12, or 12 neutrons. And since it's neutral, it will have 12 electrons. There's also magnesium 25 that exists, which still has 12 protons. It has 25 minus 12, or 13 neutrons, and it has 12 electrons. There's a third isotope of magnesium, which is magnesium 26. Still magnesium, so there's 12 protons. The number of neutrons is going to be 26 minus 12, or 14, and the number of electrons is going to be 12 because it's neutral. So as we go across this series here and look at these isotopes, we see that in each case the mass number increases by 1. And since the mass number is increasing by 1, if it's magnesium, we cannot change the number of protons, because remember, the number of protons characterizes which element or atom we're talking about. So as we go across this series here, we're increasing the number of neutrons by 1, and that's why the mass number is increasing. So we need to come up with a standard for how we're going to express what we will call an atomic mass. So in order to kind of come up with this convention, we have to come up with a standard. So the standard for atomic mass is carbon 12. One carbon 12, or one carbon 12 atom, is 12.000 atomic mass units, or AMU. We are going to use something called a mass spectrometer to measure this atomic mass. So the device used to measure atomic mass is called a mass spectrometer. And this is going to allow us to look at various isotopes. So, and to figure out exactly how many isotopes we have. So what happens is when you use your mass spectrometer, it's going to give you a readout that has abundance on the y-axis and the mass in atomic mass units on the x-axis. So if this were carbon, we would have a mass of 12, a mass of 13, and a mass of 14 on our x-axis. And what we would typically see is a graph that looks something like this. So we have a large amount of carbon-12, a very small amount of carbon-13, and a trace amount of carbon-14. So in looking at this mass spectrometer, and we're not going to have you interpret any of this data, but what I want you to recognize is that the weighted average of all the isotopes is reported on the periodic table. So we're going to take a weighted average of all of these isotopes to give the atomic mass. So we can say that the weighted average of all the isotopes is reported on the periodic table and is referred to as the atomic weight. So let's go through